welcome back to another video of my CPU project. I had to cut it short because my screen recorder was too low, but basically now I can show you what my program codes finally do. And what this does is, if you notice right here, if I put 1 in, my ALU will be adding when I press F5 to trigger the reaction. Down here, ALU is adding. When I put in 1 and then press S5 or F5 again, ALU is subtracting. And then I need to set up my multiplier, console.log. ALU is multiplying. And then I go C underscore out equals A underscore in, and then I forgot what this little like star symbol thing is called, but you use that, and then you go B underscore in, and this will multiply it now. Alright, let's see if we can find that control again. And then when we put 1 in, and then we put F5, ALU is multiplying. And then after this, we can do console.log, and then I'm going to put ALU out equals, and then we put a plus C underscore out. And then when I press F5 again, it shows what I've multiplied to. And when I add, which is 1, 1, and I press or set it to add, you'll see that it subtracts, which is 255 minus 255 is 0. And then 1 is add. And then my ALU out is 510. And then when I go back to 0 and press F5, it's ALU off and ALU out is 0. And I've set up my math, or my part of my ALU up now. But now what we need to work on is what I'm calling my split off registers. Because these are our function registers up here, but what my split off registers is what I'm going to call them, does is it basically subtracts a number till the number is 0, and it sets those numbers to 8-bit binary values. Only issue is this can get really buggy with certain numbers, as sometimes things are in between the actual values of the 8-bit binary, because as you can tell, it's a 1, 2, 4, 8, 16, 32, 64, and then 128. But there's gaps in between all these numbers because it's multiplying the last number used each bit. So the next bit after 128 is 2 times 128, which surprisingly we don't need to go anywhere for a calculator currently because I've just built one. So what we need to do is to rewrite a program to multiply, because 2 times 128 is A times B. And what I can do here now is I can reset the rest of the variables on the B inputs to only give us 128, which means the next bit of will be, I'm going to say the number after I compute it using my binary computer. And basically what I need to do now is I need to set it to 111, which is multiplying, and then I press F5 down here, and the next bit of binary for 16 or after is 256, which is weird now because we know the max of 8-bit binary is 255. So this raises a problem, and I have a fix for that problem. And basically what that fixes is what I'm calling single string or single number strings, which is 1 bit. That means a single fixed number, nothing else, just a single fixed number, and is not an actual number of 8-bit binary, which would be 1 over, which isn't too bad. I'd just add a 1 single string carryover for that. And basically with that, we are almost complete with our ALU, but eventually in one of our episodes we're going to add a divide feature, which means that we need more single number strings to carry down, because we'll be using either I'm going to use decimals is what I'm going to use, because decimals are just a lot easier to display. And if I ever actually build this thing in real life, I'm going to use 7-segment displays to display the numbers and LEDs to display individual bits. But also I do have a few other program ideas, like I do want to add in pi and stuff into this. It's going to be a whole thing. But now one of the things that I really need to do is I need to work on my split registers. So we do // which initiates a note. Hold on. And this note we're going to use to basically place a bookmark. And so you can see it's 2 times 128 down here. I just forgot to show that. And then multiplying is 256. And now we know that, we can start working on our split off variables, which are, I'm going to call split off registers. And then I'm going to use my the trusty old console.log separation with the minus to show where the new line of code is, and then we do F5 to reload and make that appear. And basically now we have our control for our ALU. We have our inputs up here, and then we have our control, and then we have our actual math part of the ALU, and then our split registers. And what our split registers are going to do is, if our number is greater than 0, C underscore out is greater than 0. Well, anyways, this video is up to 9 minutes, so I'm going to end it and make another video of my split off registers.